Dear students, in last class we studied how the voltage across the string insulators is distributed, and there for m equal to 5 we have seen voltage across second unit of insulator from the top is 1.2 times the voltage across first insulator from the top. V3 is equal to 1.64 times the voltage across first insulator from the top. V4 is 2.408 times voltage across the first unit from the top. It means that voltage across all the units in string insulator is not the same. As we move down from the top unit to the bottommost unit, the voltage across each insulating unit goes on increasing, or the bottommost insulating unit will be having highest voltage across it, or it will be subjected to highest voltage stress, whereas the voltage across the topmost insulating unit, that is first insulating unit, will be least subjected to the voltage stress. So based on how the voltage is distributed across the various units in a string, we define a new term called as string efficiency. String efficiency is something different from the efficiency of motor, transformer, etc. Because when we calculate the efficiency of motor, transformer, generator, etc., there we calculate efficiency as the ratio of output power to the input power. But in case of insulators, string efficiency is defined as voltage across the n strings divided by n into voltage across the unit near to the power conductor. And the string efficiency is measure of utilization of material in the string. It means that all the insulating units that are used in string insulators are of same type. Their voltage ratings will be same, the material used will be same, but they will be subjected to different voltage stress. It means that here we are not going to utilize the full voltage withstanding capability of an insulator. How much of the voltage withstanding capability we are making use, that we are going to calculate by calculating string efficiency. So I'll write here normally efficiency of motor, generator, transformer, etc. is calculated as the ratio of output power to input power. However, string efficiencies measure of utilization of material in the string. String efficiency neta is equal to voltage across the n strings here you have to take the meaning of string as unit divided by n into voltage across the unit near to the power conductor. Near to the power conductor means bottommost unit. This is also equal to spark over voltage of n strings by n into spark over voltage of one disc. If the voltage distribution is same across each unit, the string efficiency will be 100%. Because numerator and denominator here or here will become same. From this definition, if the voltage distribution is same across each unit the string efficiency will be 100%. Now we will solve one problem based on the string efficiency. A string insulator has four units and each unit is having capacitance C. The pin to earth capacitance is C by 10. Find the voltage across each unit of the string and string efficiency. Take line voltage as 33 kilovolt. In this question, we have been given 4 units and the value of m here and the value of m here is 10. Now we have to calculate the voltage across each unit of the string and also the string efficiency. Given number of units equal to 4, that is n varies from 1 to 4. M is equal to 10. We have to find out the voltage across each unit. Let the voltage across the topmost unit is V1. Voltage across second unit V2 is equal to V1 into the bracket 1 plus 1 upon M. That is V1 into the bracket 1 plus 1 upon 10, which will be equal to 1.1 times V1. Voltage across the third unit, can include here the V3 is equal to V1 into the bracket 1 plus 3 by M plus 1 by M square. That is V1 into the bracket 1 plus 3 by 10 plus 1 by 100. That is equal to V1 into the bracket 1 plus 0.3 plus 0.01. V3 will be equal to V1 into 1.31. Similarly, using general equation for Vn equal to Vn minus 1 plus Vn minus 1 upon M, we get V4 equal to, remember here it is small v V3 we got 1.31 times V1 plus small Vn minus 1 is equal to V1 plus V2 plus V3. These are capital V's by M. So substituting the values, we get 1.31 V1 plus 0.1 V1 plus 0.11 V1 plus 0.131 V1 plus 0.131 V1. Adding all these, we get 1.651 capital V1. This is what? This is V4. Since the line is operating at 33 kV, the total voltage across the string will be (33 kV by root 3). That is equal to 19.05 kV. That is V1 plus V2 plus V3 plus V4 is equal to 19.05 kV. Therefore, voltage across the topmost unit may be obtained as here I will substitute for V2, V3, V4 in terms of V1. V1 plus 1.1 V1 plus 1.31 V1 plus 1.65 1 V1 equal to 19.05 kV. Adding all these, we get this one here, 5 plus 1, 6. 6 plus 3, 9. 9 plus 1, 10. Carry 1. 2, 3, 4 plus 1, 5. 5.061 V1. Dividing 19.05 by 5.061, we get V1 equal to 3.76 kV. Now we can calculate V2, V3 and V4 by using V2 equal to 1.1 V1, V3 equal to 1.31 V1 and V4 equal to 1.65 V1 as follows. So here V2 is 1.1 V1, that is 1.1 into 3.76. On multiplying we get 4.14 kV. V3 is 1.31 times V1, that is equal to 1.31 into 3.76. On multiplication we get 4.93 kV. Similarly, V4 is equal to 1.65 times V1. On multiplication we get 6.21 kV. Next we have to calculate string efficiency. String efficiency is equal to voltage across the n strings by n into voltage across the unit near to the power conductor, that is 19.05 kV by 4 into voltage across the unit near to the power conductor means V4, and that is 6.21 kV into 100. On simplification we get efficiency equal to 76.69%. Next we will study methods to improve string efficiency. There are different methods to improve the efficiency of a string, and those methods are by increasing the value of m, grading of units, static shielding, and making use of conducting glazes. So what are these methods? We will discuss them now one by one. String efficiency can be improved by the following four methods. First one, by increasing the value of m. Second one, grading of units. Third one, static shielding. Fourth one, conducting glazes. We will take first one now. Increasing the value of m. We have efficiency of string as voltage across the n strings. This is nothing but phase voltage. Divided by voltage across the n strings divided by n into voltage across the unit near to the power conductor near to the power conductor. Looking at this expression for efficiency of string, we understand that if we decrease the denominator, efficiency value increases. Then how to increase the denominator is a question. In denominator we are having voltage across the unit near to the power conductor. That means voltage across the nth unit, that is last unit from the top, and that is given by Vn equal to Vn minus 1 plus Vn minus 1, here it is small v, divided by m. So to decrease the value of Vn, we can increase the value of m. If I increase the value of m, then this second term value will decrease. Second term added to the first term will also decrease. That means denominator will decrease. By that what happens? Efficiency will increase. So this is the main idea behind the first method. We'll write a few lines on it. If the value of m is increased, which can be achieved by, see, the m value depends on the length of the cross arm. You have seen the cross arm. On the pole there will be a cross arm like this. And equivalent capacitance of the insulator units we show like this. And here also we show some capacitance, and its value is given by m into C. Similarly, we will be having here a capacitor whose capacitance is m into C. Now this m value depends on the distance between the string of insulators and the pole. That is nothing but the length of this cross arm. So by increasing the length of cross arm, we can increase the value of m. We can increase the value of m, which means if the length of cross arm here is, say, LC, then m is proportional to LC. M is proportional to LC. Achieved by increasing the cross arm length so that the capacitance between pin to earth is decreased so that the capacitance between pin to earth is decreased. The voltage distribution across the unit can be improved. And thus higher efficiency can be achieved. But how much but to what extent I can increase the value of m is a question, because increasing the value of m means increasing the length of cross arm, as we have seen here. If I go on making it longer and longer, then the cost of the iron used here will increase. In the interest of making efficiency equal to 100%, the cost of the cross arm itself will become very, very high. So such things should also be avoided. Practically, it has been found that m value greater than 10 is not economical, or value of m greater than 10 is uneconomical. However, increasing the cross arm length after certain value will be uneconomical. Mathematically, we can achieve 100% efficiency by making m equal to infinity. It is found that the value of m greater than 10 is not economical. Dear students, I will stop the class here and continue in next class with remaining methods of improving efficiency of string insulators. Thank you.